So I'm going to speak about building and scaling B2B applications with MongoDB, right? And yeah, I think this is the Kickstarter for today. And in this solution, in this session, right, we are going to speak about the things that we have to pay attention while building B2B applications, and how MongoDB helps you solve some of these problems, right? With some of these problems are solved by the products that the product suite itself, which provides a lot of features to help you solve the problems. Some of these problems are solved by specific system design patterns, right? And this is the agenda where we are going to talk about what MongoDB offers for you while building B2B applications. And we are going to talk about the database design with respect to multi-tenancy, where each tenant is a customer. We are going to talk about how you would scale for different requirements, or when you're working with different set of customers, different set of industries, right? What are the scaling opportunities available for you? Right, and it's kind of like additional considerations that that you would need to think about while building B2B applications that may not exist for while you are building a user-facing application, right? So one of this is exponential scaling, and this is a very good problem for you to have. This is where you are adding more and more customers, and your customers, which are actually businesses, they are also adding more and more customers, right? So you're having scaling in two phases, right? You are adding customers, your customers are adding customers, and your application and database stack should scale to meet this challenge, right? And the second one is obviously data segregation, since you are working with data of different customers, and depending on the industry that you are serving, you need to provide either physical segregation of data or at least virtual segregation of data, right? Some of the industries such as banking, healthcare, right, these demand physical segregation of data itself. And with data segregation comes also data isolation and role-based access control. It's clear that you should be serving the correct data to the correct customer, right? There shouldn't be any mix and match. The third one is a particular problem with B2B applications, because when you are building B2B applications, right, you would need to integrate with a lot of other existing applications, right? This is a crucial part, and you might be sourcing your data from other existing applications of customers, and that brings in a lot of customization to the table. As product managers, right, so when we build a SaaS application, right, we try to keep it simple, to have a single stack and not a fragmented stack, so that it's easy for us to maintain our stack. But what happens is that when you add a new customer, let's say you're adding a new customer who is like 2x of all the existing customers that you have, they bring in new requirements to the table. They would tell you that we are using so and so for our user-facing app. You need to get integrate with that, right? You get a lot of integration questions, and that also brings a lot of customization challenges. A simple address field, right, might be a 4-liner for all your existing customers so far, but the new customer might be storing it as a 6-liner, right? You would have 6 lines of address, and if you don't have the flexibility to handle it, you would end up building customer specific mapping logic, right? Where where you would have to map their data to yours, which is complicated to maintain as you scale to more and more customers. The next option is that to have an option to provide tiering, right? Price tiering based on performance. You might have specific SLAs, right? You might want to offer a premium tier with a lower response SLA to those customers who are willing to pay that premium, right? While others might have a linear SLA, right? Maybe 500 milliseconds for normal customers, 100 milliseconds for premium customers, right? That's how you differentiate the experience and get more revenue, mine more revenue from your existing customers. Then another one could be automated asset creation. This applies more for those B2B applications that you build where you deal with SMEs, right? An example that we all can relate to is Tally, right? I mean, you would all remember Tally, right? A lot of India's SMEs run on Tally for their accounting, right? And Tally deals with millions of customers, right? So when you deal with large number of customers, right, you would need to automatically provision resources. Let's say whenever you hit, every 1,000 customers, right, you might have to automatically provision new infrastructure for them so that you can scale. Then, and this is the age of AI, and a lot of MongoDB's customers as well. Everybody is playing with fidgeting with AI, and at this point of maturity where AI has reached, right, it's more or less offered as a premium service, where you would offer a normal search for customers, and for those who are paying the premium, right, you would offer a semantic search option because it's a costly service as of today. So you need to have the capability to offer differentiating set of features to different customers, right, which necessitates blue-green deployments, and that's across the stack, right? If you are to offer a feature, right, you might be content with running a lower version of database for normal customers, but a higher version might be required to offer few additional features for the set of premium customers, right? So you need to have the capability of separating them out. The last one is staggered maintenance windows, and this is especially true for Indian SaaS companies because more than 50% of the total revenue that Indian SaaS companies bring in come from global markets, right? We are truly going global. We are building products for North America, Europe. Like, customers are coming from all parts of the world, and that makes it difficult to find a common maintenance window, right? So when it is night in US, it's peak peak work time in India, right? So finding a common maintenance window becomes very complicated. And we are going to see how MongoDB helps you solve these problems through its native tools as well as design patterns. And first is that why use MongoDB, and we are very happy that MongoDB has seen around 265 million downloads over the years. Even in our cloud service, that is Atlas, right, we have now 50,000 customers. More than 3,000 of them are from India. And what we heard from you, right, is that you use MongoDB because first it's because of the document model. We'll come to that. The second is the horizontal scaling capability. Third is the ability to run it anywhere, right? This and that's something that our community brings in, right? And a lot of you might have started with community or are still using community, and you would appreciate the stability of the product, right? Our MongoDB community is a pretty good product itself. And the first point is that the document, right? So why a lot of people choose MongoDB is the simplicity, right? The MongoDB document relates very well with the JSON, which is the modern transport means, right? So everything happens over JSON, right? And the MongoDB document can fold a JSON very well, while you might need 6 or 7 tables in SQL to hold the same data. And this, and it's also about the schemaless design as well, right? So you can have an additional address line for some customers, and you may not have it for the other customers. And this has led to a very fast adoption of MongoDB and the creation of mean and MERN stacks, right? Both of which MongoDB is a crucial part, and it has become one of the go-to application design strategies for cloud native applications, where you build with Node.js, use MongoDB as the database. And over the years, right, we also have added a lot more things to the MongoDB's database, where we initially started with full-on JSONs. We added a bit of tabular support and atomicity by bringing in join operations. The schema design patterns let you run it as a key value store. You can run text search operations, and recently in our cloud platform we have Atlas search queries for running text searches. You can run geospatial. You can keep your coordinates in the database. You can you can capture the relationships in graph use cases. In MongoDB 5 we introduced time series, which is more for IoT and the data where you get a data every, let's say, 5 seconds or a minute, right? You have numerous data points. And we had streaming, like event streams from MongoDB 3.4, which is maybe like 4 or 5 years old. And it's not just about capturing different data. MongoDB is one of the most robust, has one of the most robust querying capabilities in NoSQL space. You can run point queries, you can run range queries, you can run geospatial queries, you can run text searches, you can run aggregations, like how you would run a store procedure in SQL. You can run joins, you can do graph traversals in graph lookup. And MongoDB also supports ACID transactions, which is the reason why it's chosen for even for payment platforms, because ACID is a crucial requirement there. And other thing is that since the documents are flexible, it helps you handle uncertainty, right? It's not just that you can have additional fields in the data. You can also have query them, right? We have things like wildcard index support, where you would say that index everything that comes inside the address section of the data, right? Even without knowing what's going to come in, you can index it and you can query it without losing the performance. And yeah, as I said, you can run MongoDB anywhere. A lot of you might have started using MongoDB in your own laptop, and once you have built a prototype, you might have deployed it in, let's say, a virtual machine. And as you have scaled up and you have gone to our Atlas Cloud Service, and due to these capabilities that MongoDB offers, a lot of world's leading SaaS or B2B applications use MongoDB. Stripe deploys one of the largest MongoDB community deployments, and they last year they handle around $1 trillion worth of payments in their with their MongoDB database. And we have SAP, Expedia, Cisco, Adobe, ADP, India's own Darwin Box, StoreHippo, all of them uses MongoDB Atlas. And one of the curious things, right? At least 3 of these products, right, were built partially or mostly in Namma Bangalore, right? So that's a pretty niche thing about B2B businesses. A lot of global B2B applications are being built by engineering teams in Bangalore, and even our MongoDB team has experience working with them to scale their applications that we could share with you when you are building yours. So when you're building a B2B application that you expect to scale globally, right, do reach out to us. Even if you're running community, we would have a lot of insights to offer to you that helps you, with your journey. So in addition to the community database, right, our Atlas Cloud platform offers few more things. It offers a fully managed MongoDB, with all the bells and whistles built into it. It's truly multi-cloud. You can run it in GCP, AWS, Azure, all at the same time, or at least in one of them, right? It offers archiving out of the box. It supports CLI, API, or even infrastructure as a code integrations like Terraform. In addition to offering a fully managed database, we offer Atlas Search and Vector Search, where you can have the same data. You can run database queries on it. You can run text queries on it, otherwise you might run on Elastic. You can run vector search queries on it without replicating the data anywhere, right? The data resides in one place, and you can do all of these things. And we have charts, and we have a whole application stack built in with fully managed triggers. And this helps you reduce complexity, right? Rather than maintaining a whole host of data persistence stacks, you can work with fewer options, which makes it very easy for you to operate your enterprise stack. So we spoke about what MongoDB brings into the table, where things like integration challenges, customization requirements, etc., are handled natively by the database itself, right? You just need to use the database to solve these problems. You don't need to do anything else. Some of the other problems require design level strategies to tackle, and these multi-tenancy strategies that you use also would impact on how you are going to scale the application as well. right? Why multi-tenancy? I think you, as the those of you who are building SaaS applications, you will be very familiar and as to why you would need multi-tenancy. You would have many customers with lots of data. You need to isolate data. You need to simplify the management, reduce cost without compromising on performance. And yeah, before going to the multi-tenant strategies, right? In MongoDB, you have 3 layers. So one is a cluster, which cluster is what we call in topology as a replica set, right? Where you might have 1 or 3 nodes where all the data resides. Inside the clusters, you will have databases, which is kind of like a logical encapsulation. And inside databases, you have collections, which are like tables. And the multi-tenant strategies makes use of all the 3 layers. The first of this approach is to have a cluster level multi-tenancy where you would have 1 cluster per customer, and this makes a lot of sense for those customers. For those B2B applications that are built for, let's say, domains like banking, right? Where you offer a B2B application that's going to be used by 4 or 5 banks. These are going to be large customers, large and few customers who are going to use database, and it makes sense for you to have a different database cluster per customer. And it completely eliminates noisy neighbors. You will have complete data isolation. You will have tenant-based pricing. You can price the customer as per the size of the cluster that they are using, right? It's easy to back up and restore the individual customer's data because backup happens at a cluster level. But at the same time, right, this adds operational complexity. Rather than managing a single cluster, you might end up managing 10 clusters or 12 clusters, which can be a bit cumbersome if you are running community. But on a cloud service like Atlas, you can automate your cluster management using something like Terraform, or you can use our native API or CLI to automate things like provisioning clusters or scaling up clusters whenever there's a need arises, or you can even use our auto scaling to scale up the cluster as the customer's usage increases. So this is one of the approaches that's very unique to those applications which handle fewer large customers, right? The next one is to have a single database per customer. This is one of the widespread approaches that you are using. And like the cluster level multi-tenancy, here also you have physical separation of data, right? The data of different customers are kept in different files, and you would have 1 database per customer. And in a cluster, you will have, let's say, 30 or 40 databases, depending on the number of customers that you have. And this approach gives you, brings a lot of things to the table as well, right? So as I said, it ensures data isolation, but creating a database doesn't take any time. You can spin up a new database inside a cluster in matter of seconds or milliseconds, unlike a cluster per customer where you need to provision a new infrastructure that takes time. And you have fewer clusters to manage, and it's more cost efficient, because if you are having separate infra, even if the customer is using it or not, it will cost you the same. But when you host multiple customers in a single database cluster, you can share the resources, which makes it affordable. At the same time, since you are sharing the resources, you are going to end up with noisy neighbors. And the database access is at a data separation is at a database level. So you will have a tough time doing the role-based access control, and you need to maintain the mapping logic at the application side as to which customer maps to a particular database. And another thing is that when doing things like tuning, right, you would be for example, you might want to create an index to support a new operation, right? Here the same thing has to be replicated in a lot of databases, right, which makes it a bit more operationally complicated to manage. And also you don't get to backup or restore customers' data, specific customers' data, right? You can use things like our Mongo dump to dump the data for a single customer, but it's difficult to replicate at a large scale, right? You can do it for few customers if the requirement is very unique. So what we do practically is to do hybrid deployments. where, right, and this is something that happens naturally. Let's say you start with 5 customers in US, right? As you build the application, you start with 5 customers in US, maybe 1 customer in Europe. So initially, it doesn't make sense for you to have a separate cluster in Europe because your customer concentration is largely in US. So you might start with a single cluster in US. Maybe over time, you might get 10, 15 customers in Europe, which makes it logical to have a separate database in Europe to serve those customers, right? So you might start with a single cluster managing all the 6. Eventually, few of these customers are going to get moved out to the cluster in Europe. Or it could be the case that you might start with 5 customers. After 2 years, one of the customers have grown exponentially, while others have grown maybe relatively slower, and 80% of your workload is driven by this single large customer. At which point it makes sense to host them in a separate cluster altogether, right? Give them a separate cluster. Maybe that customer is willing to pay a premium for you. So in this hybrid approach, you might have a cluster per custom for bigger customers, and the smaller customers might share a single cluster, right? So this sounds like it's very difficult to manage, and this can also be a scaling strategy, right? For example, like as you scale from 10 to 100 to 500, you might host them in different clusters. But we have a tool called MongoSync. So MongoSync is a community product that's free for you to use. So MongoSync provides a powerful utility for you to seamlessly move the data from one cluster to other. It can also be used for things like to have a remote backup, right? You can have a active passive configuration where the active cluster is the main cluster, and for disaster recovery you can switch to the passive cluster, right? That's also a scenario it supports, but for discussion we'll talk about moving databases between clusters, right? So MongoSync can be used for you to move a database from a shared cluster to a single cluster without any downtime, and it provides API endpoints out of the box for you to start, pause, resume, commit the operation, and it also helps you do these kind of operations without any downtime, right? So you can live migrate the data from one cluster to other, and as you finish the live migration, you can commit the operation and repoint the endpoint in the application layer, right? Which makes it easy for you to scale and for your platforms or DevOps teams to operate when you're going in scale. When you're with 5 customers, 6 customers, you can do it manually, but that's not a scalable approach. And on the right hand side, you can see how the API looks like, right? So here we are moving from source to cluster 0 to cluster 1, and it provides a rich regex space filter to filter out those collections which should be moved and those which should not be moved. And so you start the operation. You can pause it by calling the API, or your script can commit the operation at the end and then complete the move. So with this hybrid approach, right, it solves a lot of problems that we initially discussed. So you can solve the problem of data isolation. You can solve the problem of having a blue-green deployment, right? Let's say if you're running MongoDB, you're running MongoDB 6 for initially. Now you're playing around with, let's say, vector search, right, which has rich support in MongoDB 7. So you spin up a MongoDB 7 cluster, and for those customers who are willing to pay the premium to use the semantic search, you can simply move those databases with MongoSync to the newer cluster, right? And as customers sign, right, you can even, since it's driven by APIs, you can even integrate it with your customer onboarding, right? You can have a webhook on Salesforce, right, that the Salesforce process will call, or your CRM will call to automatically move a customer to a different cluster, right? So this fully eliminates any kind of manual intervention in this whole process. And also, you can host different databases in different geographies, and you can get rid of the problem of doing a staggered maintenance, right? You can do a maintenance in India for the Indian customers and a maintenance in US for the US customers. So this is another approach where you will have one collection per customer, but I would call this is kind of like an anti-pattern, right? So having one collection per customer doesn't give you any benefit, and it makes it very difficult to manage. So if any of you are using it, you should consider otherwise. The last option is to have a single collection for many customers, which makes sense for domains like retail, where data isolation rules are not as sophisticated as, let's say, finance, right? You can house all the customers' data together in a single collection or single table if you are coming from the SQL space, right? Single collection, and you build this data segregation layer fully at the software layer, right? So in the database, everything is in the same place. In the software layer, you might have a field called customer ID or a tenant ID, with which you will filter data for different customers. The benefit of using this approach is that it's very easy to maintain, right? You have a single index for a query, right? If you want to optimize something, you add a single index in a single collection, right? You don't have diverse assets to manage. And there is no extra step in provisioning the cluster to a new customer, right? You just add data to the existing collection, right, without any problems. But while it's very simple, it gives like a lot of different it throws a lot of different problems at us. One is that it's very difficult for you to give performance isolation, right? All of them will have same level of performance. If there is a noisy neighbor, it's going to impact everybody. You're going to have very little observability options. In the database level multi-tenancy, if you're an Atlas customer, you can at least get performance SLAs, as in what is the kind of response time you're seeing for each customer, even though you cannot control noisy neighbors. Here, even that observability is very difficult to come in. You will never know what kind of performance each and every customer of yours is getting. And since the data segregation is purely at a software layer, you need to have really good developers, right? Any bugs in your code are going to expose, cross-expose customers' data, and you need to be thorough with your testing. And and the last point is that you cannot restore backup, or you cannot move out a customer. Even in the first two approaches, let's say one customer which was with you is moving out, and as part of the contractual obligation, right, you are supposed to delete the customer's data. So you would be terminating a cluster, or you would be deleting dropping a database. In this case, you need to find out the individual records and delete it, which makes it quite cumbersome. So for those who are using Atlas, in addition to these three multi-tenancy options, you have one more, which is a project level multi-tenancy, where in addition to segregating, having a database level cluster level segregation, you would have a network level segregation as well, where each customer's deployment will be done on different network, which helps you in compliance and auditing requirements in specific spaces like healthcare or banking, as I said. So these are the different options that we discussed. One project, that's for Atlas, one cluster per customer, a hybrid deployment, one database per customer, and one collection for all customers. Right, then we are going to talk about the scaling strategies, right? So you have finalized your database topology. How would you scale for customers? And the simplest approach is to go for vertical scaling, as you would add more and more compute. If you are in Atlas, you will use auto scaling, or as you grow out, right, you can go with horizontal scaling. So when people think about scaling in MongoDB, the thing that comes to everybody's mind is sharding, right? Sharding is a solution that people think as a scaling strategy, but to be frank, sharding doesn't apply everywhere, right? It truly depends on the kind of database topology that you have gone for. For example, if you have gone for a database topology where you're going to have one database per customer, sharding doesn't make sense, because sharding happens at a collection level. Now you don't have a single big collection, you have numerous small collections, right? There, a more viable horizontal scaling strategy could be to have an asset allocation using IOC or script. For example, let's say you're going to have a logic where you're going to house 30 customers per cluster. So when you exceed that number, when the 31st customer comes in, you're going to spin up a new cluster and have the new customer housed in that cluster, right? Or you know, it could be done manually if you are dealing with a small number of customers, or it could be automated by script, where we support more and we support different options in Atlas. With community, you would end up writing scripts yourself, where you might have to do a dump and restore, maybe a bit of over engineering to achieve the same thing. So for database level multi-tenancy or cluster level multi-tenancy, you would go with adding more clusters to your ecosystem without sharding anything. And sharding is applicable for the database topology where you will have one collection for all customers, right? So here in this case, you end up with a very big collection which houses all the data of all the customers. Then sharding can be used to scale there, and MongoDB natively supports sharding. So you just need to identify a particular shard key and you're good to start, right? So sharding can be used for increasing your compute power, right? Where you add in parallel computes when you run out of vertical scaling capabilities, right? You can add more CPU cores, you can add more RAM. For those of you who are dealing with high throughput scenarios, one of the things that you're gonna run out early is IOPS, right? So horizontally scaling might be a cheaper option if you are scaling due to IOPS, because procuring IOPS from any of the cloud providers is a very expensive thing, right? So you might add a small cluster with standard IOPS as your scaling strategy, because it would be cheaper. Sharding can be used for reducing your RTO, because let's say as you scale up and your disk becomes like, let's say you have 1 terabyte worth of disk, right? Or let's say your disk size is 4 terabytes. So each backup and restore is going to take progressively more and more time, right? And at some point your backups are gonna overlap, right? Which is very bad for our backup and restore process. So having smaller clusters of smaller disk sizes augurs well for this solving this problem. The last one is to fulfill geolocality requirements. For anybody who is working with any sort of PA data, would have to comply with data residency laws. In Europe, you have GDPR. In Australia, has their own version of GDPR, where they demand that any kind of payment or finance related application data should be hosted in Australia, right? So sharding can solve this problem for you. And we offer 3 kinds of sharding. One is hash-based sharding, that's offered by MongoDB and even some of the other databases, where you have a fully random sharding, where you create a hash of your data and use that to shard the data or segregate the data. In addition, we have range sharding, where you take a data range, like let's say you have 6 shard cluster, and you have a user ID as your shard key. Then minimum to 10 will be in first shard, 20 to 30 will be in second shard, 40 to 50 will be in third shard, etc. And this kind of rebalances as well. As let's say you are adding more and more customers on the 50 to max range, it's gonna auto balance, and this 50 is gonna go up to 60, while some of the customers that you added might go to a lower shard. We also offer zone sharding, which is kind of like a fixed key sharding, where there is no auto balancing. Let's say you have a field called region, which is EMEA, APAC, or US. All the data which has the same the field as EMEA is going to land on the shard in EMEA, and it's not going to auto balance even if that the data there in that region goes up. So this helps you solve the problem of data residency loss. And one of the other ways in which you can solve the same problem is to have a separate cluster in each region, which is something that people might be doing, but that would prevent you from running, let's say, analytical queries at a global level, right? With a zone sharded architecture, you can keep the data in different silos and still run queries across it, especially when it comes to analytics. At the same time, sharding uses more hardware, right? Even with a 2 shard cluster, right, you would have 3 nodes each if you're using the recommended approach of 3 node replica set. So that makes it 6 nodes. You would have at least 2 routers which which are represented as Mongo S here. So that makes it 8. You would have a config server, which would again be a 3-node replica set. So you end up with 11 nodes, which is a bit difficult to maintain by yourself, right? In Atlas, it's a fully managed service, so you don't need to deal with the complexity. And also, in addition to that, we are doing more and more engineering on on this field. With the new MongoDB 8, you can you can take away these 3 config servers and house them in one of the 3 nodes that you have. And also, we have done a lot of improvements on our auto balancing capability, where it's easy for you to move data between shards with a 10x improvement. And also, you have option of resharding the data again and again, as you end up with more and different query patterns. Even if you have initially sharded the cluster with some particular shard key, because of the use case that you had at that point, you have an option to reshard the same data again when when you are facing a new challenge, right? So just to culminate the session, so we spoke about different multi-tenancy options, cluster level, database level, and at a software level. For software level multi-tenancy, sharding is the way to scale, right? You have infinite sharding options. We have customers running in Atlas who have 37 to 40 shards, right? And have handle 170 to 180 terabytes of data. We have customers like Stripe, which run in community, that handle even bigger shadow topologies. And then we discussed about database level multi-tenancy, and the way to scale it would be to add more clusters and use something like a infrastructure as code service like Terraform to automatically allocate resources, and use our inbuilt tools like MongoSync to move the data between these clusters. Then we spoke about cluster level multi-tenancy. There again, the scaling strategy would be to shard the cluster, because you have a single customer per cluster, right? So as the data gets bigger and bigger, sharding is the go-to approach for scaling. And initially, when we started, we discussed different problems that a B2B application would have, such as exponential scaling. That's solved by sharding. We spoke about having blue-green deployments, staggered deployments. That's solved by having different databases, either zone sharded or fully separate database clusters, right? So that's the end of it. So if you have any questions, you can ask me now. Sure.
The distributed database should be in only in terms of storage, the GDPR compliance applies, or the application also which is accessing the data in UK should be hosted in UK itself.
Okay, so the question was that if there is a if they are running a multi-tenancy application with some customers in US and some customers in UK, whether zone sharding the cluster would solve the problem, or whether there should be an application deployment in UK as well, so to handle the compliance problem, right? So the answer to it is it's a bit complicated. So if you're working with customers, right, who works with UK entities like NHS, so they demand that the data flow through UK itself, while a lot of generic use cases only demand that your data residency should be in UK. So while you are querying it, data on the flow can be through US as well. Because to give you a simple example, right, you might have the application in UK, but let's say a customer, right, who is a UK resident might be in US at that time, and he might be using it from US. So it's very difficult to prevent the data from moving, but that most of the compliance regulations demand that the data at rest should be in the particular geography. Yes, that is data. Yeah, correct. It's correct. Huh.
UK storage can be used, right? So how to if the application is multi-tenant application, where it needs to be hosted?
So for yeah, my answer is that for most of the industries, your application can be in US itself. Okay, the data resides in UK. The application can be in US, but you would need to consider the fact that if the application in US is querying data from UK, there are going to be geographical latency, right? It has to go across the Atlantic.
The GDPR allows that.
So normal GDPR allows it, but what we have found is that when you're working with certain industries, right? Let's say customers who work with NHS is a UK's medical service. They demand that the data flow through, the data flow is in UK as well. That's been my experience.
Okay,
Right.
thank you.